In our previous session, we had seen about the fuselage design. In this session, let us start with the aircraft analysis. We have the 3D plane analysis. For analysis, click on the analysis in the toolbar and select the define analysis option. Here you can define the analysis property, like under polar type we have type 1 for fixed wing, and we type the free stream speed as 15 meter per second. And under analysis we have ring vertex, that is VLM2, and the options viscous should be unselected. And under inertia, reference dimension, aero data and extra drag, there will be no changes. Everything will be as it is, and click on the OK button. Here we get the 3D analysis of aircraft result. We can also animate it to see the lift and drag, and also the coefficient of pressure that will be acting during a liftoff and landing of the RC plane. As you can see under results, by selecting the checkbox, you can get different results according to what we want. We can either select everything and then animate, or we can check the result for one by one. Bottom right corner, we have the velocity, alpha, beta, CL/CD, CL by CD, the glide ratio, and all the values that we'll be getting for the aircraft analysis for different alpha and angle of attack. The 3D plane analysis, we have the stream flow. The air is flowing at a speed of 15 meter per second. It is the flow of the air across the flight. We can encounter vortex flow at the tip of the wing, the streamline flow at the other places. So here we have streamline flow on the other places, but at the tip of the wings, we have a vortex flow. The 3D plane analysis result for a parallel force, the color scales view of 3D panels. So as we know that put a lot of panels on each and every part of the aircraft, these are the way that the panel forces will be acting. And then we have the 3D plane analysis graph result. Once we click on the graph section on the toolbar, we will get the CLCD graph, CL versus alpha, CM versus alpha, CLCD by alpha curve, which is all explained in the previous session. So this is the output of the result of the RC plane analysis that we have done. Few points to be noted: the calculation of the dimensions of the RC aircraft parts are based on the rule of thumb. By clicking on this link below, you can actually get the website by which you can calculate the dimensions of the RC plane just the way you want. The variation in the output parameters like velocity, CLCD, alpha, beta that got on the bottom right corner is due to the change in the angle of attack, which can be changed by clicking on the highlighted box in the toolbar. And the dimensions calculation for RC aircraft is an iteration method that is to be done before designing. Make sure that the design has a glide ratio up to 75 for efficiency of flight. Now let me show how to do this in the XFLRPy software. So this is where we left in our previous session. Now click on the analysis, define analysis. We have fixed wing, 15 meter per second, ring vertex, and please unselect the viscous option. Inertia, reference data, extra drag remains same. Okay. Once that is done, click on analysis. Now this is the highlighted box that I had shown to change the angle of attack of the aircraft. Now it is in -20. So -10, 0, 7, 6.5 degrees, 13 degrees. So this is how you can change the angle of attack of the aircraft. And the result, CP or the lift, induced drag, moment, downwash, and you can also animate it. And you can see the bottom right corner, the values keep changing for different alphas. Now let us go on to the graph. This is the graph that we have got. You can also double click on the graph, select the X and Y axis according to our wish, like CD versus alpha. This is a CD versus alpha graph from minus 20 degree to plus 20 degree. So this is how you do. So now you can design and do analysis for your own aircraft model. Thank you.